Welcome to part 14, in our tutorial series on how to develop a Contras-like game, with free visual game engine Gdevelop. In this video, we are going to continue with the process of adding one new enemy to the game. This new enemy will be more intelligent than the previous human enemy, as it will be able to detect the player in front, above, or below it. It will also be able to start with different behaviors when deciding to shoot horizontally, as it will be able to do it from a crouched position. The new enemy is one of the many enemies that can be seen in Contra, and that shots at the player from different heights. To implement it, we had to search for new sprite sheets that could include some of the animations that we needed, and we ended up using this resource asset at craftpix.net, of some police characters, that in our case we are going to use as an enemy. To make all the animations needed, and since the assets downloaded were coming with the Spriter project, we ended up having to learn this new tool. Let us know in the comments if you want to see a tutorial on that. As always, in this channel let's start by reviewing what we have up to now. As soon as we spawn, you can see that the new turret detects us, and shoot at us, so we will be implementing its destruction too. The game starts to become difficult and to have all the pieces that we need to make a full game with different levels. So, let's start with this new tutorial. Open the main game events, and scroll down to the end, where we have added the external event named Turret Enemy. Add a new event, and in the condition let's select the bullet player. In the search box type collision and select the collision condition O. In the right pane, in the field object, select the turret enemy. Click OK to exit. Add new condition of type trigger once. In the actions, let's select the bullet player and choose the delete object. Click OK to close. We need to decrease the life of the turret but we don't have any. So, let's go to the scene view, select the turret object, and right-click on it, to choose the edit object variables. Add a new variable named turret life that we will initialize with 3. This means that the enemy will have to be hit 3 times before being destroyed. Let's go back to the turret enemy event sheet and add a sub-event to the previous event we created. As a condition, select the turret, and then in the search box type variable. Select the option value of an object's variable. In the right pane, in the variable field, select greater than, and in the value field type 0. Add an action. Select the turret object, and in the action search type variable. Choose modify the value of an variable. In the field modification sign, choose subtract and in the value type in 1. Let's create now, a default particle system as a feedback to the player of the damage caused to the turret. So, let's add a new action. For the object, choose one of the particle systems that we have created previously, or create a new one that suits your needs. In the action search box, type create and select create object. In the right pane for the X and Y positions, type turret.x and turret.y. Don't forget to set the layer or to game or the particles will be spawned behind the other elements on the screen. We are reducing the turret life by 1 each time a bullet from the player is colliding with it. Add a new action for the turret object, select the modify variable of an object. And then subtract from turret life 1 unit. Now, once we have reached a value of 0 or less, we need to destroy the turret. So, add a new event below. For the condition, copy the previous condition, paste it in the new event, and replace the greater than by less or equal than. Add a new action for the turret object. Delete object. Let's check if the game runs. Let's fire toward the turret to see what happens. We can see that the turret is destroyed and deleted after a couple of hits. It is time to implement the new enemy. Let's check first if we can support more than one enemy type on the basic model that we have created earlier on in these tutorials. Right-click on Physic Enemy and open up the object variables. Yes, we have it supported. We can see that we have a variable named enemy type, that will allow us to take into account the type of enemy when choosing the actions to be performed. Right-click on enemy sprite and select the duplicate action. Rename the new sprite to Enemy 2 Sprite. Double-click to edit. Delete all animations. Our new character will have 8 animations. So, create 8 new slots for the animations. We will name them Enemy Idle, to make the enemy stand. Enemy Walk, to make the enemy walk. Enemy Run, to make it run, in later more advanced AI behaviors. Enemy Hurt, for when the enemy is hurt. Enemy Fire Horizontal Up. Enemy Fire Horizontal Crouched. Enemy Fire 45. To shoot at 45 degrees up. Enemy fire and 45. To shoot at 45 degrees down. Enemy fire 90. To shoot 90 degrees up. Now for each of the animations, let's import the sprites associated with each of them. Don't forget to check the loop checkboxes for the animations where it applies. Once finished importing the animation sprites, scroll down to the bottom of all the animations, and click on the button Edit Points. Check that the options Share Same Points for all animations and Share Same Points for all frames in animation are checked, as it will help us fine-tuning the different animations. Let's adjust the origin point and create a new image point where the bullets will be spawned from. Drag the center point to be in the bottom center. Create a new point by clicking on the add sign and name it Fire Bullet. Drag it more or less to be where the gun muzzle will be. We will fine-tune it later on specifically for each animation. Click the Close button and then the Apply to return to the scene view. Drag the physic enemy into the scene view, and set its layer to be in the game layer. before dealing with the visuals or sprites of the new enemy. Let's order a little bit up the enemy's external event to start, including different options of execution based on different types of enemies. If you have not yet opened the enemy's external event sheet, time to open it. Scroll down to the bottom of the event sheet. You should see there the group objects, where the sprites' position are updated based on their physics counterparts. Let's create a new event, and add a new condition where we are checking if the variable enemy type of physic enemy is 0, being 0 the basic enemy. Drag the new event up to be right above the event where we are cycling through all the instances of physic enemy and make this last one a sub-event. Copy the entire event and sub-event, and paste them below. In the top event, in enemy type check, click on the 0 and replace it with 1. Replace enemy sprite with enemy 2 sprite. Let's go to the scene view, and in case we need it, from the top right menu selects the group object. Drag enemy 2 sprite into the scene view, near the physic enemy object, create in the previous steps. It is quite big, so let's size it down to have the right fit and sizing for the game. Set its layer to game and put it on top of the physic enemy object. Let's run the game and check what is happening. Well, the new enemy is just standing there without doing anything. But that is normal as we have not implemented any logic. Let's go to the enemy's event and copy the event condition where we are testing if the enemy type is 0 or 1. Let's scroll up to the group of instructions named enemy. Create a new event, just right before the Raycast event, and paste in the condition that we just copied. Drag the Raycast event below the new event to make it a child of it. Copy this new group of events and paste them below. Replace the 0 in the enemy type field with 1. Close the Raycast event and copy it. Paste it 3 times, once for each of the directions that we will be testing if the enemy has the player in its line of vision. Modify the field angle of each of the Raycast events, to add the following values, plus 45, 45, minus 90. These 3 angles will have the Raycast to be launched from the current enemy angle plus or minus values as we can see in the current snapshot of the video. We will need to keep these values recorded too, to be able to know what animation to be launched. So, let's go to the scene view. Right-click on the physic enemy and select the Edit Object Variables. Click the Add button and create a new variable named Player Angle with an initial value of 0. Let's go back to the enemy's event sheet to the Raycasts. For each of the Raycast events, add a new action where we will be setting for the physic enemy object, the variable player angle to the values 0, 45, minus 45, or minus 90. Copy the action to paste it in the corresponding events and modify the player angle to the following angles. So the first Raycast with angle 0, will be set to 0. The second to 45. The third to minus 45. And the last one to minus 90. These actions will tell our enemy where the player has been seen, but it doesn't do anything to make decisions or animate. Let's do this now. Right below the new events that we have created, we have an event where we are testing if the player is in range or not by comparing its value with 0, which means that the player is not in range. When this happens, then the enemy will keep walking. Let's add a new sub-event to this group. Drag it to the top as to be the first sub-event. And drag the action to change the animation to walking there. From one of the previous conditions, let's copy the condition where we check the enemy type and paste it in the events condition. So, if the enemy type is 0 and the player is not in range, we will run the enemy sprite walking animation. Let's copy the entire event and paste it below. Replace with A1 the 0 in the condition. In the action, replace the enemy sprite with enemy 2 sprite. In the event where we are testing for the box to change the direction of the enemy go right and left, add a new sub-event. Drag the flip action for the parent event into the new sub-event and copy the enemy type condition into the condition. Copy-paste the entire event. And replace enemy type with 1, and enemy sprite with enemy 2 sprite. Copy-paste the entire set for the other direction and modify the flipping to yes. Let's run the game. Nothing happens, the enemy is not moving. Something must be wrong. In reality, there are a couple of problems. The first one is that to link sprite and physic object, we use as part of the ID that identifies each object one to the other, the function link objects that is used at the bottom of the event sheet to move the sprites with the physic enemy. Gdevelop doesn't make available the link objects from the editor. You have to link them at runtime. So, let's go to the beginning of the event, where we have the event on beginning of the scene. Add a new action to create a new physic enemy at the positions of the enemy 2 sprite that you have already placed on the scene. Once created, let's add another action to link them. So, in the Add Action interface, click on the button Other Actions. Type in the search box link and choose the action link to objects. In the right pane, for Object 1, select the physic enemy, and in the Object 2 field, select the enemy 2 sprite. Add another action and set the variable enemy type of physic enemy to 1, to reflect that is the new enemy. The second mistake that we have is that when we set the enemy to be walking, we are passing the incorrect naming. It should enemy walk and not walking. Let's run the game. Now the enemy is moving correctly toward the player, and once in range, it stops. Time to make it attack. We already have the logic there, but since it was copied from the previous enemy, it doesn't work. So we need to tailor it for the new enemy. Let's go to the first of the raycasts that we have created for the new enemy. You can see that we need to change the way the variable player angle is assigned, because, as said previously, we have chosen by mistake the modify text. We need also to change the actions below, to be associated with the new enemy, which in this particular case where the enemy is firing up and horizontally, is to change the animation name from enemy attack to enemy fire horizontal up and the object from enemy sprite to enemy 2 sprite. Let's quickly check the results. Yes. We can see that it changes the animation. We need to replace the animation names with each of the animations that we have created associated with different angles in the remaining actions associated with each raycast in the new enemy, as you can see in the video. Now let's make those bullets fly toward the enemy. For it, in each of the sub-events below the new enemy raycasts, we have to change the references where the bullet is spawned to enemy 2 sprite. Let's copy this set of actions and paste them below for each of the raycasts. Let's check. Well, the bullets are moving toward the player, and the enemy is chasing it. Of course, we are only dealing yet with the horizontal direction or angle 0. Let's now apply the changes to include the direction in which the player was detected. We can apply this change to the previous system too. So for all the actions where we are applying a force to the bullets and bullets trails, after the enemy angle instruction, let's add a plus sign and enemy variable player angle. Since we are setting this angle each time the enemy detects with its raycast the player, it will hold the gap that we have to apply to the force angle to move in the direction of the player. To test it, let's move the enemy to be below the player and to move back and forth right below the spawning point of the player, with some of the blocks to change direction. Let's try it. And yes, the enemy moves and, when detecting the player, start to fire at it. The bullets and trail are moving in the right direction. The only problem is that the bullets are not being spawned exactly at the right point. This is because, if you remember, when we created the animations, we didn't fine-tune the fire bullet image point, from which the bullets are being created. Let's improve this now. Go to the scene view. Double-click on the enemy 2 sprite and click on the edit points. Uncheck the option Share Same Points for all animations. We will want to place correctly the point at exactly the right position, and we don't the engine to change it in other animations that have different points. Be careful, as sometimes between animations changes, this point can be reset back to the activated value. So be aware of it. Review the points in all frames of the fire animations. Take the opportunity to fine-tune the origin and the center points also. We will fast forward this action as it is very repetitive and tedious. When finished, click the Close button to close the Edit Points interface and then apply to save the modifications in the object. Let's run again the game. And the bullets are being fired from the right place. Let's move the spawn point of the player somewhat to the left, as to try to have the enemy detecting us from different directions, especially flipped or directly above, and see it as it points correctly in the right direction. Let's check it again. Okay. Although not directly under the player, the enemy is detecting it as above and immediately starts to shoot in the up direction. This is because the collision of the player is too big. Let's check what is causing it. But it will certainly be located in the Raycast's events. Let's look into those events. We can immediately see the problem. We are checking the Raycast against the player sprite, which is very big. We could solve this in two ways. The first one would be to modify the collision mask for the player sprite. The second way would be to check against physic player 1, which is smaller in size. It is easier to go through this change, so we'll replace player 1 sprite with physic player in all the Raycast's events. This makes also sense because if we are to change sprites to implement, for example, different player skins or a multiplayer mode, the system would not work. Let's run it again. Okay, so the enemy is not detecting us anymore, but when he flips, he is either not detecting correctly the player or not playing the right animation, as it is playing the animation that shoots at 45 degrees down. This means that when we flip the character, some of the angles that we are calculating are not adding correctly. To fix this, we need to compensate for the flip direction. At the beginning of this series of tutorials, we have already faced something similar, and we created inside of the physic enemy objective variable that keeps the direction where the enemy is moving as -1 or 1 depending on if it is moving left or right. Let's incorporate these values into the enemy logic. For that, Let's go to the events where we are setting the raycast with an angle of 45 degrees, and in both of them, in the condition, we will multiply the 45 and minus 45 by physics enemy variable direction. Then in both actions where we are setting the angle of the force to be applied to the bullet and to the trail where we are adding player angle, multiply it 2 by physics enemy variable direction. We need to do this for both actions where firing at 45 and minus 45 degrees. Let's run the game. And we can see that the enemy is firing correctly at the player. Let's deal now with its damage and death. If we tried to destroy it, the enemy would be destroyed, but the sprite would be kept on screen because in the damage function we are deleting the enemy sprite. To fix it, in the enemy damage group, let's create two sub-events where we test for the enemy type, and depending on if 0 or 1, we will be deleting the enemy sprite or the enemy 2 sprite. Let's check. If you fire at the enemy, it gets destroyed and disappears. That is interesting, but one of the community members asked us too if we could have the enemy with a life. So let's add different lives for different enemies. The first thing to do is to duplicate the entire damage event in sub-events. Now, let's go the scene view and right-click on the physics enemy object and edit object variables. Click the blue add button, and add a new variable named enemy life, and set it as a default value of 0. This is as to make all enemies by default be killed at the first shot, while other enemies with more lives to be tougher to kill. Let's also another variable that we will be using to hold the behavior that we will want for the enemy as to shoot horizontally up or crouched. Name it enemy behavior and set the value to 0. Click apply to close and get back to the enemy's event sheet. Now in the condition of the first damage event, let's add a new condition for the physics enemy, and the variable enemy life being less or equal than 0. Let's copy the condition and paste it in the second damage event that we have just copied. Replace the less or equal than by greater than. Let's remove the actions that we don't need as we are dealing with a hurt situation. So, we don't need to delete the enemy. Let's change the score added to 500. Let's remove a couple of actions that are not supposed to be here. Enemy type 0 doesn't have a hurt animation and will have only 1 life, so in this case, we don't want to do anything. In the case of our new enemy, we don't want to delete it, but rather to play the hurt animation, so add a new action associated with enemy 2 sprite, change animation by name, and in the animation name pass on enemy hurt. We need also to set up the life of the new enemy to the value that we intend for it. So, in the on beginning of scene, copy one of the actions and paste it twice. Let's change the name of variables to enemy behavior and enemy life with values of 0 and 3. Let's run the game. And we can shoot at the enemy and he will play the hurt animation. We don't that we will be able to fully kill it, as we are under heavy fire. And we are dead. Now, let's implement the different firing behavior. Let's scroll down to the ray events where we detect the player horizontally and run the animation for firing up. Let's create a sub-event, and for the condition let's check on the value enemy behavior of physic enemy. If it is 0, then we will shoot up, so drag into the actions the current change animation by name. Let's copy the sub-event and paste it below. Replace the enemy behavior value by 1 and the animation name by enemy fire horizontal crouched. Let's move to the initialization of enemy behavior, and double-click on it. In the value field, instead of 0, let's to some random generation. So, type in random in range 0, 1. This will have Gdevelop generating values of 0 or 1 at the beginning of the game, or if you associate it with a spawn point then in the spawning period. To test it, we need to have the enemy at the same level as the player. So in the scene view let's move the enemy to be on the same platform as the player. Let's move also one of the change direction blocks up, to make sure that the enemy will be moving between them. Let's run the game. Okay, the enemy is firing up. Let's run again. And now, the enemy is firing from a crouched position. Not bad for a behavior. It will give us a lot of possibilities for the level design as we will take the advantage to generate another type of enemy that can be seen in Contra, that usually stays hidden behind bushes and to get up to fire the player when in range. Based on that, we will improve the overall design of the level to place different challenges in different places of the game depending on the difficulty curve that we want for the game. We hope that you have liked this video. If it has been the case, consider subscribing, giving a like, and clicking on the notification button. If you have any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.